Welcome back. So another example for the topic separable equation. So we have this trigonometric terms: sine x, sine y, dx plus cosine x, cosine y, dy is equal to 0. Okay. So let's solve for the general solution. General solution of this given differential equation. Okay. So first thing it is, let's try to separate variables y and x. Okay. So by doing that, since this is dx and with variable x, then let's try to divide this by sine y. So if we divide this by sine y, we must also divide this term by sine y. And since we have here in terms of y, then to cancel this out, we need to divide this term by cosine x. And since we divide this by cosine x, we must also do the same here. Okay, in order for our equation to be equal. By doing that, we can now cancel out sine y, and here cosine x. Okay, and this results to sine x over cosine x dx plus cosine y dy all over sine y is equal to 0. Okay, and simplifying this, sine over cosine with the same angle x, so sine over cosine is just tangent x dx, while this part here, cosine y over sine y is cotangent y dy is equal to 0. And since we've already separated all x terms and y terms, this is already a separable equation. Okay, then after that, our next step is to integrate both sides. So we have integrate this. So we have integral of tangent x dx is just ln of secant x, and then the integral of this cotangent y dy is just ln of sine y, and then our plus c. But since we have ln here, to simplify our equation, let's have here ln of c instead of just writing c. Okay, and then to simplify this using the property of logarithm, we can now have the secant x sine y is equal to ln of c. Okay, and by further simplification, by erasing this both sides by e, or by taking the exponential of both sides, we have secant x sine y is equal to c. Right? Now this is our general solution. Or you can also separate x and y here by taking its equivalent. So we have this secant here is just 1 over cosine x and this sine y here is sine y. Okay, then is equal to c. You cannot mix this up because this angle here is in terms of x and the angle of sine here is in terms of y. But you can now multiply both sides by cosine x. So we have here cosine x divide cosine x is just 1. So we have here left with sine y is just equal to c times the cosine x. Okay. You can express our general solution in terms of this one. Okay, so it's up to you. So that's all for this video. So once again pala, we have here the given DE, and one of the technique is through the separation of variable. That's why we've tried to separate all terms of x from all terms of y, and by doing that we'd come up with this form, and we've simplified this according to its trigonometric rule or identity. Then we have the integral of tangent x dx and the integral of this cotangent y dy, and by integrating both sides we have ln secant x plus ln sine y is equal to ln of c. We've made it our constant looks like this in order for us to just for easily simplification, and by doing or by taking the exponential of this whole term, we've come up with our general solution, which is equal to secant x sine y is equal to c. And if we're gonna take its equivalent, then secant x is just 1 over cosine, right? And sine y is equal to c. Once again, we cannot combine this sine y all over cosine x, which is equal to some tangent xy or something like that. We cannot do that because this their angle is not the same. This cosine is in terms of x and this sine is in terms of y. But we can separate these terms with y and x by multiplying cosine x to the whole term. So we can cancel this out with remaining sine y, and then by multiplying c to cosine x we have c cosine x, and that leads to our desired general solution of the given problem.